Welcome to the second video in Unit 6. This is on inverse functions and relations. And we're just going to talk about all things inverse in this video. A relation is just a set of ordered pairs. Not all relations are functions, but all functions are relations. So to find the inverse of a relation, all you do is you just switch the order, and you can see that here, right? You had 1, 5, now it's 5, 1, 2, 6, 6, 2, 3, 7, 7, 6. So this is extremely easy. To find the inverse of ordered pairs, you just switch x and y. Here's some properties of inverses. Probably the most important thing you need to know is that the notation for an inverse function looks like this. So f and this superscript, this -1, denotes, it says that this is the inverse of f of x. And an inverse is a function if the original function passes the horizontal line test. Now they talk about something being 1 to 1. I don't know if you can read this or not. 1 to 1 just means that for every x there's a unique y. So you can see right here on this function, this first function right here, that for every x there's a unique y, and so this is 1 to 1. Here, however, you can see that this point has the same y as this point right here. And so this function would not be 1 to 1. Now, why is that important? Well, that means that some functions always have an inverse, but some inverses are not functions. So the vertical line test tells whether something is a function. And of course, both of these are functions for sure. But the inverse of this function is not a function. It's just an inverse. And the reason we know this is because when you apply the horizontal line test, it fails. But on this one, the horizontal line test does not fail. So this function has an inverse, and its inverse is also a function. This function has an inverse, but it is not a function. So on this screen, you can see some examples of graphs that are inverses, functions that are inverses of each other. And so like in this first one, you see this parabola, right, this pink parabola, and here is its equation. But you can see that there's this line, this blue line on both of these, and then it's kind of implied here and here. But it's actually drawn in on this one. And this is the line y equals x. So it has the slope of 1, and it passes through the origin. So 1, 1, 2, 2, 3, 3, all of those are on that particular line. And so the definition of an inverse is a function that has been reflected over the line y equals x. So you can see here this parabola, this is a function, this right here is a function. But it fails the horizontal line test. And so you can see quite clearly in the green is the inverse of this pink function. And it's not a function. It does not pass the vertical line test. If you look over here, you have the original pink line. And when you reflect the pink line across the blue line, you get the green line, right? And so these two lines are inverses of each other. Okay, you can kind of see here, if I drew a line straight through here, you can see that the functions are, they're at least symmetrical about this line, right? So I don't know that they're actually, these aren't exactly two, this is just symmetry on here. So I think I just like the symmetry of it, but it's not actually an inverse because this is just one function. This one, however, this is the exponential function, and this is the logarithmic function. And you can see that the blue and the red are inverses of each other because they are a reflection across this line. So this is what they look like graphically. And if you think about it, if you reflect this across y equals x, what you're doing is each of these are interchanging their x and y values. And so that leads us right into the algebraic method. This is the graphical method of finding inverses. But the algebraic method is going to be very simple. We're just going to switch the x and y and then solve, and that will yield us an inverse. And so, as promised, to find the inverse of a function algebraically, you're going to switch your x and y, solve for y, and then write the answer with the correct notation. So let's try it here. We're going to find the inverse of each of these functions. So we know f of x is equal to 2x minus 5. So I'm going to rewrite this as y equals 2x minus 5, right? Because we know f of x is y. And then in order to find the inverse, I'm going to switch the x and the y, and then I'm going to solve for y. So I'm going to add a 5 to both sides. X plus 5 equals 2y. Divide by 2 both sides, and I have x plus 5 over 2 equals f inverse x. And I have found the inverse of that function, which is also a line, by the way. It just has a different slope and y-intercept. All right, if I do the same thing over on this one, I'm going to rewrite this as y equals x squared plus 1. And then I'm going to switch the x and the y and solve for y. So I subtract the 1, so I have x minus 1 equals y squared. I'm going to take the square root of both sides, remembering that the answer is plus or minus. So f inverse of x, and you know, sometimes they write it like this, y to the negative 1, and that just means inverse. So the inverse of a parabola, remember, is plus or minus square root. So I've got a square root function this way and square root that way. And that's what it looks like graphically across the line y equals x. Now the last thing we want to do in this video is we want to verify whether two functions are inverses of each other. And honestly, the method that they talk here is to find the composition functions and then show that both of the composition functions are equal to x, the identity. But honestly, what I do, especially if it's a fairly simple function, is let's just rewrite this as y equals 3x plus 9, switch x and y, and solve for y. So I've got x minus 9 equals 3y. X minus 9 over 3 is y inverse. Okay, well, what is that? If you write it separately, that's 1/3 x minus 3 is the inverse function, and that is g of x. So they are inverses of each other. Now what they're saying is take f of g of x, which is f of 1/3 x minus 3, and that's going to equal so this will be x minus 9 plus 9, which is x. So that works. And then if you do the opposite, which is g of f of x, right, then you start with g. So I've got 1/3, and then I've got 3x plus 9 minus 3. So I've got x plus 3 minus 3, which also equals x, and so they are inverses of each other. So anyway, that's two methods that you can use to determine inverses. Remember that inverses are just reflections across the line y equals x. They can be determined algebraically by switching x and y and solving for y. They can be determined graphically by showing that the x and the y coordinates are switched across the line y equals x. You can also apply the horizontal line test to a graph to show that the inverse is not or is a function. So anyway, there's a bunch of methods, and we're going to practice this again in class. So be sure you've taken good notes. Watch the parts again that you don't understand, and I'll see you in class.